Hello guys, welcome to this session. In this session, we are going to cover LT, and that is long-term evolution, or you can say 4G network architecture. Here, like we have two functional part, or you can say entities. One is the access network, and another one is core network. So, okay, on the left side we have the UE and UTRAN. UTRAN and UE are kind of part of access network. Here, like UE, that is the user equipment, and that is going to connect with UTRAN, that is Evolved Universal Terrestrial Radio Access Network, and it is via UU interface that we call as the air interface. Then we have the E node B, that is the Evolved node B, and the E node B is going to connect UE to the core network via the radio interface, and it is going to manage the radio resource allocation, encryption, and cell level mobility, you can say. And it also like going to communicate with MME for control signaling and like for and to the gateway for the data transport. It also have that extra interface, so it allows like the two InnoDBs to communicate directly for handover and kind of signaling between these, and kind of ensure the data packets are forwarded during rate transition without dropping a session. And on the right side we have the EPC that we call as Evolved Packet Core, and like it is designed to purely packet switched, okay, so that it can provide some high speed data with some low latency. In here, like here we have control plane, user plane, and some external network anchor, you can say. Control plane is going to use for authentication and mobility, and the main node is the MME, that is mobility management entity. Here MME is the primary control plane node in the LTE core, you can say, and it manages the session states, authentication uses via HSS, and handles UE tracking and paging. It also selects the preferred kind of S gateway, P gateway, and like between, and it also facilitate kind of handover between these node Bs. And then next we have HSS, that is Home Subscriber Service. It is a central database, and it is containing user related and the kind of subscription related information. And MME is going to connect with HSS via S6 interface, and it is for authentication, and it is also going to verify user profile authorization via that particular interface. And then we have the user plane or data anchoring, and as gateway is the main node here. So it is act as a local mobility anchor, and it is used to route and forward user data packets. Okay, suppose when a UE moves between some node base, then S gateway is kind of the anchor point for that particular user plane, and so that it can communicate with MME via S11 interface for mobility management, and it can instruct like node B. MME is going to instruct like node B is moving from node B1 to node B2, like in case of mobility management. Then we have a packet get or PDN gateway. So it is going to provide connectivity from the UE to the external data network. It could be internet, and it is also going to provide some services like IP allocation. So here PGW is kind of responsible for IPS, like assigning IP addresses to the UE. Also, it is kind of exit point to the internet and other external networks. It is also having some S5X8 interface which connects S gateway and P gateway. S5 is used when a single P element is used, and S8 like is used during some roaming scenarios. Also in the core network we have the PCRF, that is policy and charging rule function, and like this node manages the quality of services and the charging rules. And the GX interface it is having, and through this interface PCRF provides P gateway with policy licenses like bandwidth limit or some traffic prioritization. Okay, and it ensures that user data session is not going beyond to their specific kind of subscription plan. And by separating these planes, like user plane and data kind of control plane, we are going to achieve high throughput packet forwarding for that particular, you can say, architecture. Now, let's move to next slide. So now here, like we are going to use the LTE cups architecture. So here, like cups means you have a control plane and user plane separation. So now as you transition from traditional monolithic EPC to some more agile cloud native environment in recent developments, so understanding cups is kind of fundamental for 5G evolution as well. And like here the questions comes like why we need to use that cups architecture. So in traditional EPC network, the control plane and user plane functions are kind of tightly coupled with each other, or you can say within the same hardware or virtual instances. Okay. So if you need some more throughput like some, or you can say on the user plane, you have to scale the entire gateway. Okay, in that case, you are going to waste some control plane resources, and CUPS is going to solve this particular issue by physically and logically decoupling the signaling logic from the data forwarding hardware. So here also, like if we talk about the architecture background, it is also same like we have the access network and the core network. Okay. So here you can say the entry points is the same. U is going to connect A node B via UU interface, and here E node B is splitting like into interfaces. That is, one is S1 MME, one is S1U. S1 MME is like it is going to SMM is it is going to MME for authentication among mobility, and for data it is going via S1U. So here like it is going to bypass the signaling core and goes directly to the high throughput user plane. And in the control plane, in APC control plane, it is going to handle the control plane signaling and kind of session management. So here we have the same node MME and HSS. These are going to manage the subscriber authentication mobility tracking via S6 interface that we already covered. And here like we have the control plane gateway in APC control plane. So these control plane gateway are like kind of P gateway C, PS gateway C, and TDFC. And like these core nodes are going to manage some session states, IP address location, and some charging triggers. Okay. They are going to communicate with each other via SYS C interfaces and with MME via S11 interface. Also there is having PCRF, and PCRF is going to interact with PGWC over GX interface, and also it is going to provide the same like policy and kind of charging rule. Okay, now we have separate user plane, that is APC user plane, and this is where like high throughput packet forwarding is going to happen. Here we have PJW and SGWU, and it is going to handle the actual user data packet, and they are going to connect with S5S8U interface. Here we have that TDFU, TDFC as well. So these are the traffic detection function, and here like we are going to manage some application specific traffic detection and kind of enforcement for the rules. And by adding this particular architecture, we have one more interface that is introduced, that is X6 interface, and which is kind of allows us like control plane to control the user plane, and it is based on PFCP, that is packet forwarding control protocol, And here we have the interface S6A that is going to connect S gateway C to S gateway U. S6B is going to connect the P gateway C to P gateway U, and S6C is going to connect the TDFC to TDFU. So that's all from this section. I will see you in next session. Thanks.